Fluidized bed combustion boiler. There are three basic types of fluidized bed combustion boilers. Atmospheric glassic fluidized bed combustion boiler, atmospheric circulating fluidized bed combustion system, pressurized fluidized bed combustion system. Atmospheric fluidized bed combustion system. The coal is crushed to a size of 1 to 10 millimeter depending on the rank of coal. The atmospheric air, it acts as both the fluidization of air and combustion air. The velocity of fluidizing air ranges from 1.2 to 3.7 meter per second. Almost all the atmospheric fluidized bed combustion bubbling bed boiler use in-bed evaporator for extracting the heat from the bed to maintain the bed temperature. The bed depth is 0.9 meter to 1.5 meter depth. Atmospheric fluidized bed combustion boiler comprises of following systems: fuel feeding system, air distributor, bed and in-bed heat transfer surface, and ash handling system. Fuel feeding system. For feeding the fuel, the sorbents like limestone, usually two methods are followed: under bed pneumatic feeding and over bed feeding. Under bed pneumatic feeding, if the fuel is coal, it is crushed 1 to 6 millimeter size and pneumatically transported from feed hopper to the combustor through a feed pipe. Over bed feeding, the crushed coal 6 to 10 millimeter size is conveyed from the coal bunker to a spreader by a screw conveyor. The spreader distributes the coal over the surface of the bed uniformly. This type of fuel feeding system accepts oversize fuel also and eliminates transport lines when compared to under bed feeding system. Air distributor. The purpose of air distributor is to introduce the fluidizing air through the bed cross section, keeping the solid particles in constant motion. The distributor structured from metal plate having a number of nozzles or nozzles with bubble caps. The distributor plate is protected from high temperature of the furnace by refractory lining, a static layer of the bed material, water cooled tubes. Bed and in-bed heat transfer surface. The bed material can be sand, ash, crushed refractory or limestone with an average size of about 1 millimeter depending on the bed height. These are of two types of shallow bed and deep bed. In bed heat transfer surface. In a fluidized bed heat transfer process, it is necessary to transfer the heat between the bed material and an immersed surface, which could be that of a tube, bundle or a coil. The heat exchanger orientation can be horizontal, vertical or inclined. Ash handling system. Bottom ash removal. In the Fbc boiler, the bottom ash constitutes roughly 30 to 40% of the total ash, the rest being the fly ash. Ash from the boiler outlet falls into the crusher. The crushing will take place. The large ash particle is crushed in small size. Finally, the ash is carried by high velocity air to delivery point. Next one is fly ash removal. The amount of fly ash to be handled in FBC boiler, it is relatively very high compared to the conventional boilers. Fly ash carried away by the flue gas is removed in a number of stages. First in convection section, then from the bottom of air preheater and economizer, and finally a major portion is removed in dust collector. The type of dust collector used are cyclone, bag filter, electrostatic precipitator. The diminish of sulfur dioxide, recycling of fly ashes practiced in some of the units. Circulating fluidized bed combustion. This is the taller boiling section. Coal is crushed to a size of 6 to 12 mm depending on the rank of coal. The fluidizing velocity in circulating beds ranges from 3.7 to 9 meter per second. The combustion efficiency is highest 99.5%. The combustion takes place 840 to 900 degrees Celsius and the fine particles are retreated out of the furnace with flue gas of velocity 4 to 6 meter per second. The particles are then collected by the solid separators and circulated back into the furnace. There are no steam generation tubes immersed in the bed. Advantages: high combustion efficiency, high sulfur retention degree, better limestone utilization, lower emission level of nitrous oxide and sulfur oxide, more economic, produces 75 to 100 ton per hour of steam. The capacity range is about 400 to 500 megawatt and the FBC boiler is 10 to 300 megawatt. Number of feeding point is less because lateral mixing is done by high velocity fluidizing air. This is the pressurized fluid bed combustion. In here the operating temperature is 860 degrees Celsius. The fuel is fed along with the sorbent and it is maintained in fluidized in the pressurized compression chamber. The pressurized flue gas are cleaned off and expanded in a gas turbine. In addition to the excess of air, the requirements of the boiler are met by the compressor. Power generator is in the order of 80 to 20. Advantages: improved cycle efficiency and is estimated to be 4 to 5% more than conventional steam plant. Lower fluidizing velocities, it reduces the risk of erosion for immersed heat transfer tubes. Reduced emissions and improved combustion. Reduced boiler size. Advantages of FBC over conventional boiler is high efficiency, fuel flexibility, ability to burn low grade fuel, pollution control and ash removal. No clicker will be formed. The simple operation and quick startup, no slagging in the furnace and no soot blowing, provisions of automatic coal and ash handling system and provision of automatic ignition system, high reliability and low maintenance cost. Thank you.